Okay, good morning. You're on to Mamu with Jarvis, and this morning we're looking at our grade 9 experience talking about algebra. To be specific, we'll be looking at the matter of quadratic expressions. Quadratic expressions. Now, a whole lot come to mind when we mention quadratic expressions. At grade 9, there are certain aspects of this topic that you need to understand very well. But let's start by trying to connect with previous knowledge. Quadratic is a branch or an aspect of algebra, and when we mention algebra, two key areas come to mind: expressions and equations. Every time we talk about algebra, two key areas come to mind: expressions or what? Equations. Now, what's an expression? An expression is a simple statement, simple mathematical statement. For instance, I can say A plus B. That's an expression. I can say A. That's an expression. Or I could say A plus 2. All these are expressions. They are one-sided in nature. When we talk about equations, we mean two-sided. I could say A is equal to B. That's an equation. I could have A equal to 2. That's yet another equation. Or I could have A maybe equal to 0. All of these constitute what is called or equations. We cannot talk about algebra without drawing reference to expressions and equations. Another important aspect we must remember when we talk about algebra will be the matter about certain concepts or ideas that we must not forget. We have things like coefficients, in no particular order, coefficients. We have things like constants. Let's make them plural, constants. We have things like known, which we will call numbers. We have things like unknown, which we will call variables. And by extension, we can also call them letters. I've done extensive videos on all of these, but in our topic today, we are going to focus on just one aspect of expressions. And that aspect of expression borders around quadratic. So, what then is a quadratic? Quadratic expressions, or quadratics for short. What then is a quadratic expressions? We go back a little and we draw inspiration from a topic we considered not so long ago: binomial expressions. Or sometimes we say binomial expansions and things like that. But this is the topic that will lead to a build-up on what we are talking about when we say quadratic expressions. So what is a binomial? A binomial is simply two terms connected by an addition or a subtraction. Two simple terms or simple letters connected by what? Or variables connected by what? An addition or a subtraction. By means two. Normals mean terms. So if I have A plus B, that's a binomial. If I have A plus 2, that's another binomial. If I have 2A plus 1, That's yet another binomial. So all of these are what we call binomials. So, building on this, how do we now obtain a quadratic? We simply multiply two binomials. So anytime we multiply two binomials, we obtain something rather interesting. We could obtain what is called a trinomial. A trinomial. And an example of a trinomial is a quadratic. So if I multiply these two, I'm going to obtain a binomial or a quadratic. Now, let's pause and clear this board and see how this works out. Okay, back to our case in point a plus 2 into a plus 1. We'll use the method we have been using before now. The first content of A will multiply the content of what? B. So the first content of, or the first content of the first bracket, or the first term. Now take note of something. I think I left out something that was very important here. Every binomial has two terms. If you consider this to be a binomial, which it is, A is the first term, 2 is the second term. If I consider this to be another, 2a is the first term, 1 is the second term. So if I multiply two binomials, the first term and the second term of the first bracket, the first term and the second term of the second bracket. So in multiplying or in expanding, what do? We use the first term of the first bracket to multiply the second bracket. We use the second term of the first bracket. The sign in front of the term is very important to multiply the second bracket. And what do here? We multiply out. This will be a squared plus a plus 2a plus what? 2. At this point, we collect like terms. This will give me a squared plus apples, 1 apple plus 2 apples, give me what? 3 apples plus 2. What we have obtained is what is called a quadratic expression. So, based on this example, we will now try to make general observation or make general statement of what a quadratic is. But let's look at it. Let's look at a few things we would have noticed. In a quadratic, there is always one unique unknown. What's unique unknown? A. So let's look at properties of quadratic expressions. So what are those things I would see and would tell me that this expression on the board is what? A quadratic. That's what we're going to try to do. Number one, you discover that there is just one unknown. Guess what? One unknown. And that unknown in this case is what? A. In some question it could be what? X, it could be Y, it could be Z. But in this case, there's just one unknown, and that unknown is what? A. So it has one unknown. That's it. That's just one unknown. Number two, if you look at this, there are two. I'm seeing one unknown appearing twice. I'm seeing a squared here. I'm seeing 3a. So the next idea we would add is that the unknown has, or rather, the unknown is the highest power of the unknown is what? 2. The highest power of the unknown is what? 2. And you are seeing it here. A is raised to the power of what? 2. or A is what? Index 2. So the highest index of the unknown is what? 2. So the highest index of the unknown, when I say unknown, I also mean variable. The highest index or power of the unknown or variable or letter is what? 2. Technically in mathematics, we call that degree. So if I want to now speak technically, I will say that the highest or the degree of the unknown is what? 2. So the degree of the unknown is what? 2. Or let's put it better. Let's say the degree of the unknown is what? 2. This is the highest we can ever have for a quadratic. This is the highest we can ever have for a quadratic expression. So, we look at the key ideas we've gotten now. Number 1, it has one unknown. 2, the highest index of the unknown is what? 2. And I said that this index or power is the degree of the unknown, and it's what? 2. This is the highest we can ever have for a quadratic expression. Now, number 3, it is obtained by multiplying 2 binomials. As we saw here, I seen it. We multiply 2 binomials and we obtain that. So it is obtained by multiplying multiplying 2 binomials. So it is obtained by multiplying what? 2 binomials. So anytime you multiply 2 binomials, what you obtain essentially is what is called a quadratic expression. Alright. Okay, a quick reminder here that we have 2 official texts for the textbooks for this course. We have the Essential Mathematics for Js3, and this can be found on page 84 thereabouts. And we have the New General Mathematics, and that will be found on page 88. But this remains my favorite. It's still the book. In fact, you can't get it in the market now. I don't know. It's like, since I started publicizing them, everybody wants to buy this book. So if you have a copy, please do well to let me have it, because I'm looking for them now. Okay, the method we use to obtain the quadratic expression is what is called direct multiplication of the binomials. Direct multiplication of the binomials will generally help you obtain the quadratic expression. We'll start with that, and then we will now go into what I call the no-show method. That's what we call it. It's a method I've developed, and I trust that mathematicians will pick to it. It's called the no-show method. It's a no-show method. It requires you looking at the question and telling and answering the question in your mind. So you can actually look at 2 binomial terms, or rather 2 binomials. You multiply them together mentally and get the answer very quickly. So let's try these techniques out. Okay, so we'll look at exercise 9A of our New General Mathematics on page 88. So if you can grab a copy of that, that will help you to flow with the class. Exercise 9A, question number 1. It says, exercise 9A, New General Mathematics. That's the acronym for that. Number 1 says A plus 2 into A plus 3. So let's try to expand that. Okay, so we're using what I call the direct product method to obtain a quadratic expression. The direct product method to obtain a quadratic expression. It's just similar to what we had done previously. In the direct method, we pick the contents. We pick the contents of the first bracket and use them to multiply the contents of the second bracket. So I pick the first content, I use that to multiply the container. So it is contents of first bracket multiplying container of second bracket plus, so when we say container, we mean everything in the bracket. So container will mean everything, content will mean pick out one. So we pick the content of the first bracket, the first content, and use it to multiply the container, and then use the second one. Now the sign in front of the term is very important. So the content of the first bracket multiplying the container of the second bracket. So you do that. So this is what you're going to obtain. You notice that the container will appear twice. And with that you can expand. A times A will give me A squared, and A times 3 will give me plus 3A. Take note of the sign. Pay particular attention to the sign. Plus 2 times A, and that will give me 2A. And then 2 times 3, and that will give me 6. At this point, we try to collect like terms. And what would that give you? A squared plus 5A plus 6. What we have obtained is the quadratic expression. Because we said that by the direct product method, we multiply two binomials to obtain the quadratic. So this is a quadratic. Please pay particular attention to this because much later we will start from here and move backwards. Just like counting your A, B, C, D, E, E, D, C, B, A. So we're going to do that very soon. Okay, still on that same exercise, because we are trying to ensure that what we have learned has stuck. Remember, there are two words we're using: contents and container. I have two containers here, and in each of the containers I have two contents. In this I have content C and plus 6. You must pay attention to the sign. And in this container I have content C and negative 1. So if I'm going to convert this by way of direct product to our quadratic expression, I will take the content, first content of the first container, and multiply every container, all of the second container. I will pick this plus 6, which is the second content, and use it to multiply the second container. The next thing I simply will do is to expand. So you see, it's a callback to what we have done earlier. You see that every topic you learn in maths, there's a connection. So sometimes when you struggle with a new idea, it's not the idea you're struggling with. You're essentially struggling with something you ought to have known that you have not known. So you may want to go back. I think when I was in grade 8, I did an extensive work. If you go to my playlist on the Mamu experience, look for algebraic expressions in the grade 8 playlist. You'll be able to see how we carry out binomial expansions, and I think that will suffice for that. So this will give me C squared. Why is it C squared? C is multiplied twice. Plus or minus C plus 6C plus times negative will give me negative 6. The next thing we want to do is to collect like terms. I'm going to emphasize something at the end of this. This will be C squared. Now, I have more. than I'm owing, that means I have. So it will be plus 5c. Come again. I'm owing and I have more than I'm owing, that means I have. So that will be 6 minus 1 minus 6. I like that, I'm rich. So that will be 6 squared plus 5c minus 6 as my final answer. Now, please notice something. Order is very important. I started with to the power of 2, to the power of 1, and no power. I started with to the power of 2, to the power of 1, and no power. You must take note of this. This is the standard way we write quadratic expressions. From power to no power, from power to power 1 to no power. From place of maximum strength to place of intermediate strength to place of no strength. Okay, so let's take some more examples. Now, 2 contents. Each content has 2 containers. Did I get that right? 2 containers rather. 2 containers, in each container having 2 contents. Beautiful. So I pick the first content in the first container and multiply all with the second container. So content, container. Now, here you need to pay attention to the signs. 2c times c will give me 2c squared. Let's do a little callback. 2c times c means 2 times c times c, which will mean 2, and then c times c, which will give me what? C squared. Remember, a number letter times a letter will give me what? A number letter or a number letter squared. A number letter times a letter will give me a number letter or a number letter squared. Make this learning interesting for yourself. That's it. Mathematics is an interesting subject. Very interesting. Now, minus 2 times 3, 6, c. This is negative. This is positive, so my answer must be negative. That will be negative 5c. Negative times negative will give me what? Positive. And that will be 15. Alright, so with this, we collect like terms. This is 2c squared. I'm owing. Remember we said that whenever you see 2 negatives, it's addition you're performing. If I say negative 6c minus 5c, this I can write as negative 6c plus negative 5c. A reference to your directed numbers. So this one will mean from start at negative 6c and move back 5 steps. So you are essentially going to have negative 11c plus what? 15. So this is your final answer. Remember, as a check to see whether our answer is right, you must have great power, intermediate power, and no power. So every time you generate your answer, you must always look out for this. If it doesn't go in this way, likely that answer may not be correct, although there exists an exception to that. Okay, so thank you for joining Mamu with Jarvis this morning on the concept of quadratic expressions. What we've tried to do is to introduce the concept of quadratic expressions and to show you what is called the direct product method. We will continue with the no-show method. Thank you very much, and don't forget to subscribe to my channel as we upload more Mamu mathematical multiverse questions. Thank you very much.